Hi everyone! In one of the previous videos, I showed you why and how I installed a heat pump in my shipping container house. And today I suggest we continue along the same lines because I'm going to show you my thermodynamic water heater connected to my ventilation system. Most importantly, I'll explain how I installed everything. Hi, I'm Julian Malara and this is my container house. I'm 26 years old, I have no do-it-yourself experience, but I set myself the crazy challenge of building an eco-friendly and affordable house. I'm also trying to develop my resilience and live in harmony with nature. I'm filming and posting all of this on my channel, so subscribe to follow the adventure. Let's start simply by asking ourselves, what is a thermodynamic water heater? And above all, why would it be more interesting than a regular electric water heater? The thermodynamic water heater uses a heat pump to extract heat calories from the air and transfer them into the water stored in a tank. The principle is the same as the heat pump I showed in my video. The process is much simpler than a conventional electric water heater, which just uses a heating element to heat the water. On average, a thermodynamic water heater is so efficient that it uses up to 3 times less energy than a conventional electric water heater. On the product's energy label, for example, you can see that a conventional electric water heater from Sauter should consume 2,665 kilowatt hours per year on average. If we take a thermodynamic water heater from the same brand, we see that it should consume about 952 kilowatt hours per year, which is almost exactly 3 times less. 1,713 kilowatt hours less. And at $0.23 per kilowatt hour, well, that's still a saving of 390 euros per year, knowing that the classic electric water heater costs 525 euros compared to 1,500 euros. For its thermodynamic version, that means your thermodynamic water heater pays for itself in 2.5 years. This doesn't factor in the significant rise in electricity costs expected in the near future. So there's really nothing to think about. A thermodynamic water heater is much more economical than a conventional electric water heater. And it goes without saying that if you save energy, you'll save money, but you'll also significantly reduce your impact on the environment. So it's easy ecology, right? It's a win-win, so you might as well do it. Let's discuss the details of the water heater you installed. It's a thermodynamic water heater, but as you can see behind me, it's a pretty special water heater. I would even say it's unique on the market. Since it's connected to my ventilation system, that's what those pipes you see going off on either side are for. For reference, it's the Tiflo Hygro Plus from Aldi's, the same brand as my heat pump. As we saw just before, a thermodynamic water heater works like a heat pump. It will draw heat from outside air or a garage to heat the water in the tank. When the air outside or the air in the garage is cold, the system still works, but it's less efficient because there is less heat energy in the air. Whereas if we use the air at room temperature inside the house, well, we would gain a lot in efficiency. That's why the Tiflo is connected to the ventilation system. It draws in the stale air at room temperature, heats the water as it passes through, and then expels the cold air outside under my house. When you look at the energy label, you can see that it's actually an even more efficient system. Since we should be consuming 344 kilowatt hours in Num, which is almost 3 times less than a standard thermodynamic water heater, this should save about 140 euros in electricity per year. But the Aldes water heater costs twice as much as the Sauter one. So is it really cost effective? To do the math, you first have to take into account that in a house, you absolutely have to renew the air. So you need a ventilation system. You have single flow ventilation systems. They suck the stale air out of your house and expel it outside. It's effective for renewing the air, but we lose a lot of energy because it's like having a window open all the time. That's why the double flow ventilation system was invented. It simultaneously draws in stale indoor air and blows in fresh outdoor air. The special feature is that it exchanges the heat between the 2 airflows to keep the warmth inside the house. A typical double flow ventilation system consumes about 300 kilowatt yearly, costing around 70 in electricity, and is expected to lower the heating bill by 15%. In my case, that should save me 35 euros per year. The Aldi's Tiflo Hygro Plus, with its built-in ventilation, functions more like a single flow ventilation system. But it allows for as much or more energy savings than a double flow ventilation system. Depending on the type of heating and the overall insulation of your house, you could sum it up like this with the Tiflo. Compared to a standard thermodynamic water heater plus a double flow ventilation system, I would save about 140 euros plus 35, so that's 175 euros per year. A Sauter double flow ventilation kit costs 1,145 plus 155 for ducts and accessories, totaling euro 1,300. If you install a thermodynamic water heater and this double flow ventilation system, it will cost you 1,500 plus 1,300, so that's 2,800 euros. With of course 175 saved annually, the Tiflo becomes more profitable after 4 years of use. And it's worth noting that the Tiflo's virtual network computing is more powerful and less noisy than the one from Sauter. So to sum up, we have here a solution that is very efficient, very economical, and therefore very environmentally friendly. But these aren't the reasons why I chose this water heater. I'll explain to you. The main reason is that I have a house made of shipping containers and I've kept the containers exposed, so I don't have a false ceiling to hide my ventilation unit. That's why, for example, I had to make an exposed system. So I needed to find a system that was as compact and as aesthetically pleasing as possible. And over there, the Tiflo solution was much more interesting than if I had installed a double flow ventilation system, which would have taken up much more space and would have been less aesthetically pleasing. So now, you know everything. You know why I chose this thermodynamic water heater combined with the ventilation system. It's time to explain how I installed everything. The explanations I'll provide will be applicable to all. The water heaters, as there's nothing specific about the installation, except for the ventilation system, which we'll see later. I suggest we start by looking at how to install the water heater, and then in a second step, we'll see how to install the ventilation system. The first step is to know where you're going to place your tank. You see, I put mine as close as possible to my manifolds, which will distribute the water throughout my house. That allows me to have a system with very little heat loss, because between the water heater and my manifolds, there's very little distance to cover. And above all, overall, actually, I designed my entire plumbing system to be very compact so that it's easier to install, maintain, and even use. On the lower part of our water heater, we have our cold water inlet, and on the upper part, we have our hot water outlet, which will supply our entire network. The first step will be to install dielectric fittings on both ends. Why? To protect them from corrosion, it's mandatory to put on some Teflon before screwing the part in. Let's start with the hot water outlet. It's going to be very simple to connect. I take my flexible pipe with a diameter of 20. There's already a gasket inside. I screw it in gently. There we go. And then it will directly supply the system. Over here, my hot water manifold, which will distribute hot water throughout my house. On the outlet, I don't need to install a thermostatic controller because I have a water heater where I can set the water temperature very precisely. But if you have a standard electric water heater or a solar water heater where you can't precisely choose the temperature of the tank, it's important to install a thermostatic regulator that will help prevent you from getting 80-degree water when you turn on the tap. What? Next, for the cold water supply, there are a few more components installed, but you'll see it's just as simple. We always start with our electrical connector, and then we're going to install this part called a safety group, which will regulate the pressure inside the tank. I'll explain why. One of the big problems with global warming is that hot water takes up more space than cold water. That's why sea levels are rising, which will soon engulf several countries. Yeah, it's the same in a water heater. The water heats up in the tank, and there comes a point when it takes up too much space and it might make the tank explode. That's when the safety valve steps in to release a few liters of water and reduce the pressure in the tank. It's also equipped with a check valve so that hot water doesn't flow back into the cold water. And with a siphon so that sewer odors don't come back up into the water heater. And then at the end of the siphon, I connect a polyvinyl chloride pipe to link the system to my drainage network. It's estimated that when a 200-liter water heater goes from 10 to 80 degrees, it can lose an average of 5 liters of water. When it goes from 10 to 50 degrees, it loses about 1.5 liters. To avoid wasting this water, you can install an expansion tank that will collect the excess hot water and send it back into the water heater. When it empties, it costs about 100 euros and it's pretty easy to install. So you see it here in a spot that's empty because I didn't put in an expansion tank. Why? Because I was about to tell you that, well, I have a thermodynamic water heater where I can set the temperature to 50 degrees. I'm not going to use it every day. I live alone, so I'm not going to waste a lot of water. So it wasn't economically worthwhile for me to install one. If you have an electric or solar water heater set to 80 degrees and lose 4 or 5 liters of water each time, it's economically beneficial to install an expansion tank. Then Fred from All Day reviewed my scenario and told me, but Julian, even if you lose 1 or 2 liters here and there, remember, France has 30 million households. So that can quickly add up to tens or even hundreds of millions of liters of drinking water that are wasted needlessly. And from an ecological point of view, it's just stupid. He's absolutely right. So this spot here will soon be taken up by an expansion tank. I'll have to install it. I'll provide resources in the description to guide you through the process, but it's not very complicated. Last drain left. Here, it's only a few drops, not liters. Because the heat pump inside the water heater creates condensation. So we need to get rid of those few little droplets. There you go. With this transparent hose that I just connected after my siphon, there you go, it's almost done. But there's still one very important thing left. Actually, this is my cold water inlet hose that I'm about to screw under my safety group. And it's going to supply the water heater. Now, let's focus on the ventilation system installation, which is specific to Tiflo and Gross Plus. So, you see, above the water heater, I have an air outlet and an air inlet. Let's start with the air inlet. I'm starting with a galvanized T-pipe with a diameter of 160, and on top of that, I connect a vent behind my wall in my kitchen. Then I continue with a polyvinyl chloride pipe with a diameter of 125, which is more aesthetic because it will remain visible. And I reach the vent in the bathroom. Then I continue with a smaller polyvinyl chloride pipe, 80 in diameter, which goes all the way to my toilet, where my last vent is located. The kitchen vent is humidity controlled, adjusting its opening based on humidity levels, and is battery powered. Because I can connect a switch to boost the suction, the bathroom vent is humidity controlled and operates without a battery. And in the toilet, the vent is powered by a battery and has a presence detector to manage the suction power. When you take a big poop, it's really a big pile of crap. Yes, YouTube, I said big poop. You can demonetize my video, I don't care. That's what sponsored videos are for. I don't need YouTube money anymore. I can say whatever I want. Anyway, the water heater will suck in all that stale air, then remove the heat calories to heat the water, and will expel the cool air over here. So here I came to install a Calogane with a diameter of 160, which guides the air under my containers. I could have also gone out through the wall or the ceiling, but making a hole in my roof with all that insulation or in my wall was much more complicated than making a hole in the floor. One last thing about all these elements, you see, on this side of the wall, we have big fittings that aren't very aesthetic. It's not a big deal because here I'll have a large blind that will cover everything. And on the other side of my partition wall, well, I have fittings that are much more aesthetic, much finer, because they'll remain visible. I made this choice because I didn't really have a choice due to not having a false ceiling. If you have a false ceiling, again, you'll run everything through there. You won't leave anything visible. But I'm pretty happy with it. I managed to find the right balance between the originality of the container house and the all-in-one system from Aldes. In conclusion, I hope it was clear in the video. But don't go for a standard electric water heater or even a gas water heater. Go straight for a thermodynamic water heater or a solar water heater. It'll be much more economical and much more environmentally friendly. In this video, I heavily promoted the thermodynamic water heater as a solution I really like and have installed myself. But the water heater with thermal panels, so the solar water heater, is also a very interesting solution, both economically and environmentally. I didn't choose a solar water heater because it requires a slightly more complex installation and it's maybe a bit more expensive to buy. It might also require changing your lifestyle habits a bit. Because we don't have sun all the time, so we don't have hot water all the time, or for example, when there's no sun and during the 3 or 4 months of winter, we have an electric heater that compensates and still heats our water heater. I'm unsure if this solution would have been more ecological or economical. I'll let you discuss it in the comments. It could be the topic of a future video. And above all, I know I'm repeating myself, but I didn't go with a solar water heater because I needed a very compact system. With an integrated ventilation system, so the Tiflo, and much lower, it was the perfect solution for me. Compact, efficient, eco-friendly, and economical. And just as a little anecdote, it's a choice I made 2 years ago when we did the report on Bruno's container house, which made me want to build my own container house. Well, Bruno had the Tiflo and much more, and he explained to me how practical it was for the ventilation system and all that. And since that report, I knew I wanted to install that water heater because it was very compact and very well suited to the style of house I chose to build. Then I contacted Aldes and they agreed to sponsor. That's really what I'm telling you. So it's not because it's sponsored, it's because I absolutely wanted that product. All references for the water heater and ventilation system explained in the video are listed in the description. Feel free to check my sources if you wish. Feel free to ask questions or add to the video in the comments. I'm happy to respond and discuss further. If I forgot to mention certain things, thanks for watching this video to the end. I'll see you soon on this channel for the next part of the adventure, especially the end of the cantonier's house. Because I can feel it, we're getting to the end. When you start thinking about hot water and a shower, it means you're not far from living in it. Well, I hope so. See you soon.